We have completed the chapter of inverse trigonometry. To sum up whatever you have studied so far, we started off with domain and range of inverse trigonometric function. So to understand that, there is a graph of which you can calculate what is the range, what is the domain of an inverse trigonometric function. Okay, and for all the six trigonometric functions. Now, after that, we discussed about couple of principal values as to suppose if you have sine inverse of half or cos inverse of 1 by root 2 or tan inverse of 0, what exactly are these values? Because for every inverse trigonometric function, there's a particular range of values, isn't it? So for that, you're going to have a particular angle. So the whole point of inverse trigonometry is the inverse trigonometric function takes value as the domain and gives angle as the range. Correct? We saw the graphs also. Then we moved on to properties of inverse trigonometric function. Correct? Different properties are there. We started off with very simple things like having a negative number within the value, like tan inverse of minus x or secant inverse of minus x. And we have three functions, three: sine, tan, cosecant, as in sine inverse, tan inverse, cosecant inverse. They have just minus of that particular inverse trigonometric function. For the other three, which is cos inverse, cot inverse, and secant inverse, we have pi minus the particular inverse trigonometric function. This is wherever we have negative values, isn't it? Now, after that, what do we have? We started off with different properties, especially with relating to the complementary angles, isn't it? So, sine inverse of x plus cos inverse of x is pi by 2. Same thing goes with the rest of the complementary angles, tan and cot, secant and cosecant. Correct? Then after that, we discussed about the reciprocal functions. Sine inverse of x is cos inverse 1 by x, sorry, cosecant inverse of 1 by x, or secant inverse of x is cos inverse of 1 by x. The reciprocal functions also we discussed. This is one of the properties of the inverse trigonometric function. Then after that, we did properties based on tan inverse, isn't it? Tan inverse, 2 tan inverse of x, we can represent in terms of sine inverse, cos inverse, tan inverse. When we did in terms of sine inverse, we did it as sine inverse of 2x by 1 minus x square. In terms of cos inverse of 1 minus x square by 1 plus x square. And in terms of tan inverse of 2x divided by 1 plus x square. Okay. Now, guys, bottom line, remember, for every type of problem, there is a trigonometric function involved in it. I'm talking about trigonometric function, what you guys studied last year. Since you have trigonometric functions involved from the previous year, please go through those things first. Sine 2 theta, sine of a plus b, tan 2 theta, tan of a plus b, or 3 theta, multiple and submultiple angles. Whatever the trigonometric functions and formulas you have, the same inverse trigonometric functions you are going to have. Okay. Now, this is the summary of the whole chapter, whatever you have learned so far. Okay. Now, this is inverse trigonometric function. All right. And we are concluding the chapter by summarizing the formula, whatever you have learned so far, and application of those formulas in the problem.